Okay, so number 4. Given the equation, so here we have to complete the square first to get this into standard form. So we've got y equals, and I'm going to take these two things. I'm going to move the 50 all over because these two, remember, I want a perfect binomial squared. So I'm going to factor, so I'm going to take the 3x squared minus 24x and then move the 50 over. Looking at these two, I'm just going to factor out a 3. I've got x squared minus 8x plus something. I've got my plus 50. Whatever I add here, I have to account for over here. Okay, so to complete the square, I've got half of -8 is -4. Square that, I get plus 16. But that 16 is being multiplied by a 3. So I really added 3 times 16, or 48. Okay, so I have to subtract 48. Because that way my equation will still stay balanced. If I added 48 to the right and then subtracted 48 from the right, I really added 0. Okay, so now I've got y equals 3 times x minus 4, quantity squared, and then I get a plus 2. Okay, so my vertex is going to be 4, comma 2. Now this is where it gets tricky. This is 1 over 4p. Okay, so multiply both sides by 4p, 1 equals 12p, and p is going to equal 1 over 12. Okay, now this is going to be hard to draw on this graph, but I'm going to do the best I can. My vertex is 4, comma 2, 1, 2, 3, 4, 1, 2. We know that this is going to be pretty skinny because when the a value is that big, it's going to be skinny. We also know it's super skinny because that p value, which is the distance from the vertex to the focus or the vertex to the directrix, is tiny. That's really small. It's going to be hard to draw on here. So 4, comma 2. I know it's opening up because it's y equals x squared. My a value is positive, which means I'm going to go up a distance of p. So I'm going to go up for my focus. I know I can't draw that to look like it's 1/12. I'm going to make it look a little bigger than 1/12. So that's going to be 4, comma 2 and 1/12. And if I go down 1/12 is my directrix. Okay, so that's going to be y equals, and that's 1/12 down from 2. So y equals 1 and 11/12. Okay, you could call that y equals 23/12. Okay, the axis of symmetry is this thing. It goes through it's up, down. It goes through the x-coordinate of your vertex, so x equals 4. The focus, we said, was 2, comma 2 and 1/12. You could call it, sorry, 4, not 2. Four comma 2 and 1/12, or 4 comma 25/12. Okay. Now my symmetric point, so this is opening up. Now remember the distance from the focus to the directrix is going to be your focal radius. So that distance is 2/12 or 1/6. So I could go 1/6 to the right, and it's to the right of the focus. So 1/6 to the right and 1/6 to the left. Okay, this is not going to be the easiest thing to draw. Okay, but I go 1/6 to the right, so that's going to be 4 and 1/6, comma 2 and 1/12. And we want to go 1/6 to the left. So 3 and 5/6, comma 2 and 1/12. Okay, that's just going to give you 2 points that are symmetric. They don't have to be, it doesn't have to be those 2 points, but just any 2 points that are symmetric with each other. Okay, let's go to the next page. Okay, so this one's going to be a similar one. We have to complete the square, but now this is x equals y squared, and this is negative, so it's going to open right, left, and since that's negative, it's going to open left. Sometimes I write that down right at the beginning because it reminds me. I've got x equals. Remember, I'm going to look at these first two terms, factor out the negative 1/2. I've got y squared. I need negative 1/2 times something gives me positive 4y. So that's going to be a negative 8y plus something. Okay. And then I move the minus 9 over. Now half of that squared is going to be plus 16, but that 16 is being multiplied by a negative 1/2. So I really added negative 8, which means I have to add 8 to have to keep the equation balanced. I basically added 0. Okay. Now I've got x equals negative 1/2, and I've got y minus 4 quantity squared, and minus 1. Okay. My vertex is negative 1, comma 4. Okay. And this is opening left. So negative 1, 1, 2, 3, 4. It's opening to the left. Let's find our p-value to see how far to the left. If it opens left, that means that our focus is to the left. You're always opening towards your focus and away from your directrix. Okay, so 1/2, that value is equal to 1 over 4p. So you get 4p equals 2, or p equals 1/2. Okay, so I'm going to go 1/2 to the left. That's going to be my focus. So if I'm at negative 1 and I go 1/2 to the left, that's going to be negative 1.5, or negative 3/2, comma 4. Okay, on the axis of symmetry is this line right here, horizontal line, y equals 4. The directrix, I'm going to go same p distance but to the left, and that's going to be 1/2 to the left from the vertex. Okay, or a vertical line of x equals, I go at negative 1, I go 1/2 to the right, I'm at negative 1/2. Okay, now for my symmetric points. I'm going to find my focal radius. The distance from the focus to the directrix is a total of 1. I want 1/2 left, 1/2 right, which means I'm going to go 1 up from the focus and 1 down from the focus. Okay, which gives me a value of the focus is there, negative 3/2. I go 1 up, so that's negative 3/2, comma 5, and negative 3/2, comma 3. I go 1 down. Okay. Again, it doesn't have to be those 2 points, but any 2 points that are mirror images of each other. It's easiest to find those 2 points, the 2 endpoints of your focal diameter. Okay. Now let's just look at a couple of these down here. These are a little bit tricky. I'm going to make them just a little bit bigger so we can see a little better. Basically what we're doing, we're going to find the general equation of a parabola that opens left. If it opens left, it's in the form of x equals y squared. And your 1 over 4p is going to have a negative in front of it. So x minus h equals negative 1 over 4p times y minus k squared. Let's find our vertex. That point, the vertex is 5, comma 4. That is not 5, comma 4. That vertex is 7, comma 2. Now we have to find one more point that is actually on the parabola. Okay, so that's this point up here. It's hard to say. So I was going to try the y-intercept, but that doesn't look like it hits right at 5. Okay, we don't want to deal with fractions. It looks like this point right here at 5, comma 5, that looks like it's on your parabola. This might not be an exact science because it's hard to know for sure that that passes through, but I'm going to say that passes through 5, comma 5. So first I'm going to plug in this point so that x minus 7 equals negative 1 over 4p, and then y minus 2 squared. Okay, if I can find my p-value, I just plug in the p. It's kind of hard to count, figure out what that p would be. I almost want to find a point. If I go 2 this way, I would have to go up 4 and down 4 so that my p, so the focal radius is 2p, so I can go up. That doesn't quite work. It looks like it's going to be a little less than that. Okay, let's find it. Let's plug in another point on the parabola for x and y. So I'm going to plug in 5 for x. 5 minus 7 equals negative 1 over 4p. And then 5 for y, because that's a 5. 5 minus 2 squared. So I've got negative 2 equals negative 1 over 4p times 5 minus 2 is 3, so times 9. Okay, so negative 5 minus, what did I do wrong? Oh, that's not a 5, that's actually 4. 1, 2, is that 4? Let's see, 1, 2, 3, 4. Yeah, I'm sorry, this point right here is not 5, 5, it's 4, 5. Okay, 4 comma 5, which means I'm plugging in a 4 for x. I'm sorry, it's 5, it's 5 comma 4. No, it's 5 comma 4. Okay, so your x is your 5, the 4 goes in for y, so I'm going to plug in that there. That works out nicer. 4 goes in there. 4 minus 2 is 2 squared, gives me 4. These 4's cancel, so I get negative 2 equals negative 1 over p, and you're going to get p equals 1/2. Okay, so plugging that p equals 1/2 into your equation, that kind of makes sense. If I go 1/2 over, then I would go double that up and double that down. That looks like it makes sense. Okay, so I've got x minus 7 equals negative 1 over 4p. So I'm plugging the 1/2 for p. 4 times 1/2 is 2, so negative 1 over 2 y minus 2 squared. No, don't be fooled. That's not 1/2 because you don't put the p there. It's 1 over 4p. And when I plug in 1/2 4p, I get 1/2 times 4 is 2, which means there's a 2 in the denominator, and there's still the negative out front. Okay, let's do one more. Let's do this one over here. Okay, so this one opens right. So this is going to be in the form of x minus h equals positive 1 over 4p times y minus k quantity squared. X equals y squared opens right left, positive because it opens to the right. My vertex is right here at negative 7, negative 1. You could count over negative 7, negative 1. Okay, now I want to find another point on this. Well, let's plug that in first. So we've got x plus 7 equals 1 over 4p times y plus 1 squared. Okay, this one we could try to guess. Over 2 up, 1, 2, 3, 4. Actually, I'm guessing that's going to be right here. I'm guessing the p-value is going to be 2. But let's double check. If we take a point like negative 5 comma 3, 1, 2, 3, 4, 5, 1, 2, 3. So negative 5 comma 3. Oops, there goes my pencil. Negative 5, 3. Plug that in. So negative 5 for x equals 1 over 4p. And then plug in 3 for y. So that gives me 2 equals 1 over 4p. 3 plus 1 is 4. 4 squared is 16. Okay, so we get 2 equals, that reduces to 4 over p. 2p equals 4, or p equals 1/2. Very nice. So when we plug that in, 1 over 4p is equal to 1 over 4 times 1/2, which gives you 1 over 2. So you're going to get x, we'll go back here, x plus 7 equals 1 over 2, not 2. Let's do this again. P-value is not 1/2. 2p equals 4, our p-value is 2. Okay, so when we plug in a 2 into 1 over 4p, 1 over 4 times 2 gives me 1 over 8. I'm plugging in that p-value 2 in for p right there. 2 times 4 is 8, 1 over 8. I've got y plus 1 quantity squared. Okay, there's our equation. Let's see, that makes sense because our p was 2 over 2 and we went up 4, down 4. Our directrix would be over here. Our focus would be here. So this point right here would be the same distance from the focus as it is to the directrix. Okay. Okay, I'm not going to do the last two. I'll do them and I'll put them in the solutions in the answer key that I post. But I think I've talked long enough. Thank you all for watching, and I will talk to you soon.